sailing view that a young man's life was one more ride. Taking hope, standing guard till it crossed my mind. I was wrong, all alone. All that I needed was to have needed Hakuna Matata. What a wonderful phrase. Hakuna Matata. Ain't no passing craze. It means no worry for the rest of your days. It's a problem-free philosophy. Hakuna Matata.
Good morning, Blue. That was Hakuna Matata by the Baja Men, going out to Mike, and it was picked especially for Dad by the kids.
Good morning, Houston. What a wonderful song. And I'd really like to thank my kids for that one, both Sydney and Casey. And it's a really good day to wake up today and nothing to worry about. Just a lot of work to do. And Blue Shift is ready to start another good day of science on orbit.
Roger that, Mike. I would like to thank him, too. It got us all going.
And ignition sequence has started.
Copy.
Payload Commander Mike Anderson has started the ignition sequence of the softball experiment. This is the structures of flame balls at low Lewis number. The flame balls that are being formed are only able to be formed in a microgravity environment, and this experiment hopes to improve the understanding of lean combustion to help engineers design engines with better fuel efficiency and reduced emissions.
Mike, no need to respond. I just wanted to let you know we have visual confirmation on the ground that we have 3 flame balls, and the radiometer readings are good.
And they look great from here.
Lean burning, which is mixing in more air and less fuel, is better for the environment. The flame balls seem to be shining as bright as stars, but only because they are being observed in the dark by a video camera with an image intensifier.
Yeah, I concur. I see just a tad bit of white.
Under normal lighting in a space module, the flame balls would be invisible to the naked eye and to fire detectors, and thus potentially hazardous. Scientists are hoping that the data from this experiment can also be used to protect spacecraft from fire by determining the flammability limits in microgravity. Flame balls are the weakest fires yet produced in space or here on Earth. Typically, each flame ball produces only 1 watt of thermal power, and by comparison, a birthday candle produces 50 watts. In previous experiments with the softball-type experiment, scientists expected that the flame balls would extinguish or drift into the chamber walls in a few minutes. Instead, most could have burned for hours had they not been automatically terminated after 500 seconds. The softball test points for each of the burns during this mission will use 5 gas combinations: hydrogen-air, hydrogen-oxygen-sulfur hexafluoride, hydrogen-oxygen-carbon dioxide, hydrogen-oxygen-carbon dioxide-helium, and methane-oxygen-sulfur hexafluoride. Data from this experiment may also be able to provide a better understanding of pre-mixed gas explosions in confined spaces, such as those that occur in underground mines. This softball experiment is being conducted in the Combustion Module 2 facility, which provides experiment control, containment, diagnostics, and communications for on-orbit fire-related experiments.
Coach, if you have a moment, we'd like to take a moment to recognize some folks that we don't see, nor do we hear, but we know they're doing an outstanding job every day when we get our execute packages and our new timelines. And I'm referring to the FAOs, the Flight Activity Officers, led by Terry Schneider and Tom Gately on the payload side. Also, there's Al Coffrin, Doug Bristol, and Alan Bartos. And oh, by the way, while we're at it, we'd like to sing Happy Birthday to You. And this is for Jennifer Clevenger. We know it's her birthday today. So on behalf of the blue crew and the red crew who are currently asleep, Happy birthday to you, Jennifer.
Willie, we wish everyone that you mentioned was here to hear that rousing adieu that you gave, and I really feel like we got cheated. We didn't hear the whole happy birthday song, but we really do appreciate all that. Thanks.
Scorch, I think you can finish it off for the rest of the control room.
I think we'll spare them.
Columbia's pilot Willy McCool is working on calibrating the MEDEX experiment, the Mediterranean Israeli Dust Experiment, by pointing the camera in Columbia's payload bay at the moon. You can see that here in this live view from the instruments for the MEDEX experiment.
את אותם הדברים אבל לאט מה אתה רואה כשאתה קם בבוקר ברובם אני לא מוצא אותה אחת לא מוצא אותה אחת מה אתה שומע כשהרוח מיילדת את השיר העצוב שלא נחתם שנמאס לי כבר לשמוע על הסף ולשמוע על הסף
Good morning to the Red Team. We are looking forward to working with you for another great day of science. That music was for Ilan. It was Ma'ata Oshe Kishiata Kamba Boker by Eric Einstein.
Good morning, Linda and all the team of the flight directors. It's great to hear your voice speaking Hebrew. And the sentence you just talked is, what do you do when you wake up in the morning? So I'm smiling here. Everybody is smiling here, and we are happy for another great day in space for great science.
And now we have a live downlink from the Space Lab Double Research Module in Columbia's cargo bay. This is submission our Israeli payload specialist, Ilan Ramon, on the right. With Columbia pilot Willy McCool just dismounting from the exercise device, cool up a little bit late. Work in this video, coming down to us now from Columbia, involves the ARMS experiment, the Advanced Respiratory Monitoring System, a European Space Agency series of experiments looking at changes in the body in response to the zero-gravity environment. Mission Specialist Kalpana Chawla here in the right part of your picture. She's been working with the softball experiment that experiment designed to measure low-intensity flames about 1/50th of the intensity of a birthday candle.
And Columbia, we are set up with a PAO camcorder, and you should be able to pick that up. Just let us know.
And Casey, we are on board and have a nice view.
Great. And South Columbia will go ahead and begin the softball test sequence, if that's okay, and hold when we are supposed to.
That's affirmative.
Here we're seeing a live downlink from Columbia. This is the STARS experiment. This experiment, this particular part of the STARS experiment involves carpenter bees. These carpenter bees, or spice bees, are part of an experiment from Liechtenstein studying the behavior of carpenter bees in microgravity. This is another view of this carpenter bee experiment from Liechtenstein. STARS is an international educational payload in which students from 6 countries developed biological experiments in order to promote interest in scientific education and careers. This container houses orb weaver spiders from Australia. This enclosure houses 8 spiders. Only one is involved in the experiment each time, leaving the other 7 spiders with some time off. These spiders are light-colored and not particularly attractive by human standards, but they do weave very symmetrical webs. The purpose of this experiment is to see how the spiders produce webs in the microgravity environment of space, and also to examine the content, the chemical contents of the filaments they produce for these webs. This again is the silkworm experiment from China. It studies the development of silkworm larvae, pupae, and adults, and it also looks at the production of silk and the cocoons that are spun. Columbia was launched with 5 silkworms on board and 3 silkworm cocoons. Now we've moved over to a U.S. experiment involving ants. This is the study of an ant colony and its behavior, particularly its tunneling behavior in microgravity. The medium through which these ants tunnel is both a nutrient, food for the ants, and a structural housing of their tunnel activity. This is another view of the ant activity, part of the Space Technology and Research Student Experiment. Students from 6 countries have put experiments on board Columbia, and the idea behind having those experiments on the shuttle is to promote an interest in scientific careers. This experiment is a chemical garden from Israel. It examines the production and geometry of crystalline fibers in microgravity in order to better understand their formation on Earth. This is another view of the chemical garden experiment. This is a Japanese aquatic experiment. It's studying the effects of microgravity on a closed aquatic ecosystem. It uses Medinka fish embryos. And this is another view of that Japanese experiment. This live downlink on NASA television is the astroculture growth chamber. We're seeing roses grown in space with the idea that their plant oil and odor might change, perhaps enabling the development of new cosmetics and new food flavors. This commercial experiment is from the Wisconsin Center for Space Automation and Robotics in Madison.
Just wanted to let you know if you can see the corner back where Ilan and I are. It's a real busy corner. There's a lot of payloads back there. We have to get in and out of the TEM, the TEHM, which is right behind Ilan, and that's where the bulk of the CM2 work goes on. So that's a busy little corner.
Thanks for orienting us there, Laurel. Appreciate it.
This is Mission Control Houston. You're looking at live video from the Space Hab Research Double Module in the Columbia Payload Bay, watching Israeli payload specialist Ilan Ramon working in the maroon shirt, and mission specialist Laurel Clark, both of the red team, finishing up their activities for the day. You can see what a busy and crowded place the Space Hab Research Double Module is, jam-packed full of experiments from more than 70 international researchers.
In Houston, Columbia.
Go ahead.
Yeah, are you guys still in the module?
I don't know. It depends on what you're going to do. We're with you.
Okay. Well, Ilan just reoriented the camera so you can see the part of the forward Space Hab module where we do the arms runs. Dave spent all day yesterday doing that, and Ilan did the same today. Mike will spend the bulk of his day doing that today, and I get to do it tomorrow. It's a great little setup over here in the corner.
Great, Laurel. Thanks again for showing us around.
Okay, well, good morning or good evening as the case goes for all you guys working around the clock there in Houston. Red shift is just finishing up their day. Blue shift is eagerly awaiting their flight day 9. Dave Brown, our expert camera operator, videographer, is operating the camera now. So I guess, I don't think you've seen much video of the forward part of the module because the view is better toward the back when the camera's mounted. In the forward part of the module, to the right, as you're facing the front of the orbiter, starting up here, we have one of our fresh lockers. There's actually 3 fresh lockers altogether. 1, 2, 3. Get my crew notebook out of the way. We also have the arms modules that power all the electronics of the arms ergometer payload. That's Advanced Respiratory Monitoring System. Yeah, you guys saw the ergometer a little bit earlier when I was setting up the software. As I said, that's been pretty intensive ops for the last 2 days for all 4 of us payload crew members. Let me see. Anyway, this is all the arms hardware over here. You can see there's a bag where we have the ergometer for launch over here. Can't see it. Okay. And working our way up here, again, we're on the forward bulkhead of the Space Hab module. Okay, sorry. We have our Mr. payload up here. We have the Mr. payload. We have some of our electronic data management system here. And working our way over to the port side on the forward bulkhead.
Looks great, Laurel. Just to be advised, you have about 2 minutes of video left.
That's a copy, Scorch. We've got a Fab 4 centrifuge over here. We've got a bunch of stowage. You can see as you move your way back on the port side of the module where all the VCD pieces get stowed, and that's also where we do the bulk of our Fab 4. We'll give you some more footage at another time. We hope you guys have a great evening.
Hey, Laurel, thanks a lot for that tour.
You betcha.
And we'd also like to thank our cameraman.
Yeah, 2 big thumbs up for Dave.
And Ilan, you're not so bad either.
Ilan is very handsome, but here comes Dave Brown at you too, live from space. And as you know, he used to be in the circus, so he's very, very happy here in space.
Yeah, but can he juggle in space?
Yeah, you got a point there, Scorch.
Unless you're talking about the timeline.
Well, our fantastic timeliners do all the juggling there. We're just following orders up here and having a great time.
You guys need to keep up the great work. Thanks. And we'd like to thank Dave for the triple Lindy demonstration.
I don't get no respect.
So Ilan has taken over filming here for Dave. Are you still in the module, or should we go forward and do some other stuff?
We're still with you for a little bit longer.
Okay, well then Ilan's showing the aft part of the space hab module.